Hello and welcome everyone to this presentation or webinar or whatever it is about mastering the curl command line. So this is me. I'm Daniel Stenberg. I am the lead developer. I founded the curl project a long time ago. I work for Wolf2Sell. That's my website, and that's my Mastodon account if you want to follow me on social media. So today I'm going to talk about curl, the command line, and focus on a lot of, I'll talk a little bit first, get everyone up to speed about the project, then talk about new things that we've done in curl, relatively new, I mean, in comparison, and something around transfers, URLs, JSON helpers, and some HTTP tricks, and something about a future. And yeah, let's hit it. So there's a Q&A. Ask anything and I'll get to it in the chat or in the QA thing on Zoom. Hopefully, I'm not going to be too vague and hard to understand, but who knows? So the project curl started a long time ago, right? In November 1996, actually, I got the program called HTTP GET, just a few less than 200 lines of code. It became URL GET in August 1997. Then curl was born in March 1998. We made libcurl in August 2000. And since then, it's been curl. Well, since 1998, it's been named curl, and we've been working on it fiercely for a long time. So one important thing that we're doing, or try really hard, is that we don't ever break existing functionality. We don't break scripts, command lines that already works for you. And this has helped curl, and primarily then libcurl, maybe to be used in pretty much anything, everywhere, by everyone who wants something that makes internet transfers from a client-side perspective. So it's in, cars, trains, TVs, whatever, everything. It really, really has conquered the world, and we've done releases a lot. So we do releases frequently, all the time, and it never ends. We have done, as you can see in this little graph, more than 250. I think we're at 260 soon over the years at a pretty regular pace. We have increased the number of lines of code in the project regularly and steadily through the years. And we have added a lot of command line options to the command line tool, the tool that I'm talking about today, right? We're talking about command line tool, not libcurl, the library. So the command line tool is then, of course, using the library to do all the network transfers. Right, and 265 command lines starting in the next release, curl 8.10.0. That's going to be released next week. I'm going to do another stream about that then, so join me then for that. But anyway, today I want to take a little moment and focus on maybe that little part, the top right of this graph, right? Things we have added over, maybe the last 5 years or something. Things that have not been around since forever, so maybe you haven't really used these things, a lot of these features, and you haven't seen them that much in scripts and everything. And of course, to be able to use these things, and a lot of what I'm going to talk about today is you want to use a fairly recent modern curl version, right? Because otherwise, of course, these features will not be available in your version. So, for example, we have made it easier, better, and more flexible to control transfers when using curl. And in particular, we a couple of years ago now, more than a few years, we added support for parallel transfers. Traditionally, curl has always done that. All the transfer, all the URL you provide on the command line, curl would do them serially, one by one by one. An infinite number of URLs, really, because it supports, well, not infinite maybe, but pretty much boundless. You can just boundaryless to provide how many you want. And starting a few years ago, we added the -Z option, or -- parallel, which then makes all these transfers in parallel instead of serially, which in some cases can make a really significant difference. Because why wait for the first transfer to complete before you start the second one or the third or fifth or so on? And by default, curl will then do up to 50 of them in parallel, concurrently, simultaneously. And you can change that parallelism with the parallel max option too. So you can do, I think, up to 300 by default. So if you want to do more in parallel, just ask it to do that. And it works for both uploads and downloads. You can do a lot of parallel, well, either way. For example, this little thing, just if you want to download 1000 JPEGs with a single command line and do them in parallel, zwap. Easy peasy. And another tiny little thing that we introduced, not a biggie, but it's the --no clobber. It's an option we've pretty much been inspired from other tools. Basically, it asks curl to don't overwrite something if it's already there. So if you want to download a file and the target file is already on disk, curl will not overwrite that file, which it does otherwise. So it'll add a number instead. So in this case, if I make a file, hey, I'll just hide myself or move myself so I'm not there. So if there's a file in place on disk and then I download some, in this case, I use capital O, and then the file would become the same name right on disk. But since there already is a file called file, stupid name to use in an example, then it will instead create file.1, and that's the one it downloads. So, and if there's a file.1 on the disk when it wants to create it, it'll do the .2 instead, and .3, .4, .5, .6. Actually, I think up to a .100, and then it'll fail instead. So don't do that. And we have this remove on error, which is this is a very useful thing, especially if you have, for example, you run curl in a cron job or automatic things in a script that might fail at some point, which transfers tend to do every once in a while. So then you ask curl, don't save any leftovers in case of error, because in that case, curl could very well just save something or leave something that is incomplete, not the full file, just some rubbish, right? Half of a download, what do you want that for? So then you just ask curl. So if you set it, for example, a very perfect example is if you have a timeout, allow this transfer maximum 2 seconds to complete. What if it's very slow today when you run this? So it will run for 2 seconds and it doesn't complete within those 2 seconds, but it has downloaded a certain number of bytes and they are stored on disk. Except when you say remove an error, because then it'll remove that those traces, those leftovers, the rubbish gone. So when it timed out, there's no file left afterwards. It is pretty convenient, and it is really convenient in combination with this very brand new option that's new in the next release. It says skip existing, which means skip the transfer skip the download if the target file is already present on disk. Yeah, it comes the next version. So in this case, we had the file called file on disk already, and we ask curl skip existing if it's already there, and then it'll just bam, it's done already because it's already on disk apparently. So we don't do the transfer. Also, one of these things that's a small functionality, but it's still one of these features that has been requested, and users have been wanting to do things like this for a fairly long time. So now finally it's here. And of course, the combination might be what you really want here. So skip existing and remove an error. The perfect combination, maybe. In the next release, other things we have fixed is really ways to change or control transfers while they are ongoing or before they are started. I'll show you. For example, we've had this. This is an old option. This has been around since the beginning, I think. This is an option to say if the transfer runs slower than this many bytes per second, and it's that slow for this many seconds, like if it's below 50 bytes per second for 30 seconds, then kill the transfer. Something is wrong. The bandwidth is too poor, kill it. That's an old established thing. But nowadays you can also do, all right, here, sorry, I forgot I had this example too. And you can also say, in many cases, for example, when you have a shared bandwidth, maybe you just want to download something, you don't want to make your transfer, you spend all the bandwidth, so that you want the rest of the household or network to be able to do what they need to do. So you ask curl to limit the bandwidth, whatever the limit rate. So in this case, this example here, don't transfer faster than 100K per second, and it'll just slow down so that it won't on average download faster than 100K per second. And if you would set a limit that is higher than you can actually reach, it'll just do as fast as it can. And as I showed you before, this example, you can download 1,000 images from a file in a single command line, and that's cool, right? But sometimes if you download those 1,000 files from the same server, the server might think that you are a little bit annoying because you do that as fast as possible. Maybe that is too fast for the server, because I don't know, again, you decide. Maybe the file is updated every 5 seconds. You shouldn't do that faster than every 5th second or minute or hour or something. And then you just ask curl to limit the rate, and that's the -- rate option. Don't do faster request rates than 2 per second in this case. So it'll download these 20 files, but only 2 per second at the max. Or you can, that's a very flexible option. So you can say, no, 3 per, don't do it faster than 3 requests per 2 hours, or 14 requests per 3 minutes. So it's a very flexible time syntax there. Just to make sure that you don't overload the server, you can just control curl, tell it to be slower than it otherwise would. Because if you don't use the -- rate, it'll of course do it as fast as it can, which could be fine too. In many cases, that's actually fine, but sometimes you just want to slow it down. And you can, of course, also these days truly set the maximum file size. And what I mean with truly is that back in the day, this actually didn't always work. But now you know that if you do this max file size, you can be sure that with a modern curl, it will never, in this case then, if you set the -- max file size to 238 megabyte, you know that the curl will never download the file. It will never get larger than this on disk. So in some other cases, you could sort of, if you don't know how big the file is, it could surprise you because something might happen and you get a very, very big file. But now you can tell curl, no. If you get something bigger than this, then it's an error, fail, abort, get out of it. We also have made it easier for you to fiddle with the URL a little bit. For example, the query part of a URL, you can manage that a little bit easier. The query part being, that's why I show you this URL template over here. You see the query part is the query part there is then the thing after the question mark, right? But that's also supposed to be URL encoded. So there's a little bit of a challenge to get that right sometimes. So, and that's the query part is usually a number of name value pairs, search equals a search keyword or size equal blah, 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 something you're asking for. So it's usually a number of those. Like this, name is Daniel, the tool is curl, and I'm very old, the age is old. But you can now add those to the query part of URL with this --URL query and provide the content. I'll show you a few examples why this is interesting. For example, if you want to add this hey and parentheses as query string to this URL, it'll create this query string. And as you can see here, how convenient it is that it has URL encoded the thing for you, because in a script or something that is quite complicated. Or you can also have it named, to add a name value pair like this, and then you get it. And in this case, there already is a query right on the URL from the beginning, but it'll add the new one at the right side, and so on. You can do more, read it from a file, you can encode, and it'll URL encode the stuff from the file. Quite convenient, or just add exactly what you want to do. This is something previous that was really, before we added this option, it was really complicated to do with curl. And now I'm going to just address two questions that I've received while I've talked about this. First, the question about skip existing, if it's using a file name or a hash to know that the file already exists. It's really, really simple. The skip existing thing, it just checks the file name, the exact target file name. So it doesn't actually know if it's the same file or different file or anything. That's up to the user here. So it'll just, if there is a file when you're already on disk and you're supposed to download a file to that target, then it skips it if it's already there. So because curl can't know in that case if it's this, I mean, if the file might be different on disk and on server, then you should use a different option. Then you should probably use e-tags instead. I'll talk about e-tags in a second. So it's a very simple file system based, just what's there. Someone also asked about why it's a URI and when there's a URL, and really, yeah, it's really a mix. There's URI is the correct name for the RFC 3986 thing that we in every day call a URL, but there's also this thing that everyone is calling it URL, and curl is not really strictly adhering to the RFC 3986, so we are actually calling it URL too, because that's what everyone says. So that's it's possibly more correct to say URI, but no one actually says URI, so we say URL. The fourth example here says name at file. You know, the specific syntax for --URL query, you should really read up about it in the man page, but it is a little bit weird, but it's actually correct on the slide. And I wanted to just remind everyone, we have this config file concept. It's also ancient. It's been here for, I guess, forever, pretty much. Command lines in a file. It's a text file. Every single line in the text file is basically a command line option and argument. And it's a convenient way to just save a command line or reuse a command line or share a command line, or sometimes even make a very, very long command line, because a config file really has very, very liberal limits in what you can provide, and a regular command line is limited usually. So there's also a default one, the .curlrc file, which is loaded by default if it exists. So you can set a default option like that if you want to, and you can provide a capital K or --config to ask curl to use this particular config file. Right, and one convenient way is that curl can read this from standard input as well. You don't have to provide it as a file on disk, and this is in particular useful. For example, you can make a script or a program that generates a config file on demand, right, and just pipe it into curl without having to save it on disk, because why save it on disk if it's dynamic and it's a one-off. And it can be huge, right? There's a 10 megabyte line length limit, line length 10 megabytes. So pretty much, yeah, you can pretty much provide a binary. I mean, basically your imagination here is what limits this the most. It's very convenient. But one thing the config file cannot do easily, or could not do easily, is variables. So if you want to bring in environment variables, something flexible, change things, we introduced the -- variable concept a while ago, a few years ago actually. So this is a way to set a variable on the command line or in the config file, and this makes the curl command line maximally flexible, and I'll show you some examples. Pretty much it's like this. You set a variable name to something. And why would you do this? I'll show you in a second. This brings a name with content into the command line parser. Right, you can also use it in the config file, then you set it like that. And you can set any amount of variables. There's really no limit. And every variable can hold up to 10 megabytes of content each if you want to. And they're just, you just set them in a left to right order, and you can set them with contents from a file, which is possibly what is most convenient here, because then you can read from a file, set it in that variable name, and then use that. Could be anything, secrets, usernames, binary contents, and you can read it from the standard in. And it might be binary, as I mentioned. And you can also import a name from the environment an environment variable, basically. So, and then you just prefix the variable with the %sign. So in this case, it creates a name and it imports the value from the environment variable. And you can set a default if it doesn't exist. And this way you can, or you can set the default from a file name as well. And this way you can then use the name and expand them in the command line. So for example, you do it like that. You ask curl to expand by using the -- expand when you use an option. So if you get a variable, that in this case it's the name of the variable is content, and you can post that with curl with this expand data content. And the content name here, of course, you have set that earlier with the -- variable, and you could read that from a file, or you can get it somehow, some other ways. And then you can, for example, set a URL that depends on these two variables called host and user. And those host and users could also then be from the environment or whatever. This lets you, for example, blah, 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 blah. It lets you create config files that can then use, for example, you can import environment variables and be flexible, use in more situations. And you can then, when you then, for example, if you get contents from a file, you can also apply some functions to these, to the contents really in a variable. And I'll show you why that is fun. You do then just name : function, and then you apply that function on the contents of the variable called name. For example, you can do many functions. So we have these 4 functions so far called trim, JSON, URL, and B64. So you can, in this case, this example, it sets the variable called uppercase data with a % there, means it's an environment variable that it gets into the command line, and it'll send a post because it's -- expand, and the data there, which says post this, and then it takes the variable called data, which we have imported as an environment variable, and it'll trim it first. Trim means that it'll remove white space from the beginning and the end of the data chunk that it got, and then it'll be B64 encoded, base 64 encode the data, and send that in the post in this to this site example.com. So this is then a convenient way to send base 64 encoded data that you set in an environment variable called data when you invoke curl. And just as an example, and of course there are many ways you can use this, your imagination again. Moving on, we introduced a command line tool called TrueRel, a separate tool. This is not curl anymore. I just wanted to get into this because this is something we in the curl project have done. So this is a separate tool that just parses and manipulates URLs. If you use command lines, you write scripts, and then you use curl. It's a very common use case when you use curl, that you sometimes you do more than just one single invoke, and you want to work with the URLs. Maybe you get a URL input, output, and sometimes you want to manipulate the URL. You want to change things, the path, the query, the whatever. And everyone who has written shell scripts that are working with URLs have come to that point when it's kind of complicated to work with URLs, because URLs are not that easy to parse and understand and extract and set different components in and out of a URL. So this is a companion tool then. So for example, you can, if you want to change the host name in a given URL. So in this case, provide a URL, update the host name. Provide a URL, get the host name, and just show the host name from a given URL. Or redirect. If that's the original URL and you want to redirect to this new relative URL, what's the new one? Or you can provide it a URL, set the port number, and see how does the URL look now. So basically all of these just manipulates or extracts, manipulates components of the URL or extracts components of the URL. You can append a new query part to an existing URL. You can get the entire URL exported as a JSON object. You can do these, and then you can combine also. You can set a lot of things and get it as a JSON, or you can get just a particular query name, one of these query name value pairs from the query part. As you can see in this example, there's it says after the question mark, there's a equals home, here equals now, and this then. And in this example, it makes a get of the query, and it's a colon A there, means that it only gets the A value or the A name from the query value part. So it'll show just home in this case. And it can do a lot more than this. And it's really just, this is a streamlined tool just for parsing, manipulating URLs. It's a really effective use, effective companion with curl. And one of the really sort of major points with using TrueRel in combination with curl is that they use this exact same URL parser. So you know that the way TrueRel understands a URL is the exact same way that curl understands that same URL. And that's a good thing security-wise, because that's has been and continues to be a common source for problems and the mistakes and everything, because changing URL parsers, having one parser do one thing and then pass it on to the next with a different parser risks introducing security problems, because URLs are tricky. Also, another thing we have introduced in the curl project since not that long ago is the wcurl tool. Wcurl is just a tiny tool. It's actually a shell script that is meant to only download URLs without having any additional parameters. So just, wcurl and a URL, that's all you want, or a number of URLs really, because it's, again, that it can actually download many URLs, and it'll just download them into a sensible name in your local directory. It uses curl under the hood. It's meant to be that simple, that use case. It is addressing that use case that we have heard from so many users that curl is difficult to use or to remember which options to use when you just want to download a URL down to a file. So this is basically another way, or one way, to download a URL to a file. if that is what you want. And if you don't want to remember the curl command line options to do it. And yes, the TrueRel name and the robot there is a little bit of a tribute to Stanisław Lem, who is the author of a book in which there's a character called TrueRel, who is a robot. Moving on. Move, JSON. So yes, JSON is popular. Everyone likes JSON, and we are doing our part to help JSON users get even more JSON. For example, we have this option called --write_out. It's -w in the short form. It can output information after a transfer is complete. It's a very useful option. You really should know about this. You should use it in your scripts and as often as possible. You do it like this, curl -w formatted string, and this formatted string is a way to just output the data, and it has a lot of variables in there. I think there's over 70 write_out variables now that you can use to output different kind of data, results, information, status from the previous transfer. You can also read that output from a file, that's formatted string output, or from standard input like that. This says over 50 variables. I think it's wrong. I think it's more, but it doesn't matter. And it also, so this is an example, right? Here's an example that shows you the content type of the response and the response code. It just selected those two variables, and then there's a URL, and you get that output after the transfer is done. Convenient. You can then nowadays also get the entire thing as JSON. So you use this -w, and then you use this special variable called this percent sign, and then the braces JSON and close brace, and it will output all those information variables as a single JSON object. Blam, 50, 60, 70, and growing data points in the output. So everything you can possibly want to know about the transfer in a single JSON blob for you, for your JSON fans. It's really convenient. And then if you want to massage that using a JSON tool like JQ or something. And as a reminder, then also that -w also have this fun server header response header feature that can help you get the contents of a particular response header output. Like in this case, this example here shows the response header contents for the header called server and the header called date, and it'll just show them server and date. Really convenient. Saves you from grepping and doing mistakes when trying to parse whatever output it could otherwise be. And of course, JSON, it's convenient. We also have this --JSON function, not function, option, which is setting the correct headers when you want to post a JSON blob object to a server like that, curl --JSON, or --JSON reading the JSON from a file and posting that, and it'll then set these headers. This is just a convenience thing, just an easy way for you to do JSON posts easier and in a correct way. Really convenient. And of course, I like to mention this other tool called JO, which is a really cool tiny tool to generate a JSON object out of a name value pair. So in this case, this makes a JSON object with these members, then the name, n, parser, blah, blah, blah. And it'll pass it on standard input to curl, who will then send a post with the correct JSON headers to that server. And if you then receive JSON maybe also in this, then you can pipe that output conveniently to JQ, of course, JQ being sort of the de facto JSON parsing manipulator tool. So in the coolest case, you do JO, curl, JQ combinations like this, and JSON everywhere. And we've done other things to help you do things better. And I want to just to remind you all about the --trace and --trace ASCII options, because they can really help us, everyone, to understand better more what curl is doing. Like in this case, I actually did that command line, curl-d moo --trace curl https curl.se, and this is the output, because it shows everything pretty much about the transfer, what curl is sending, getting, and thinking about. So bam, 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 a lot of data output. And if that is not enough, we also have the trace config option. I should just mention, and since I got the question, how trace is different from -v. -v is just a subset of trace. So -v is sort of the light version. It just shows you a little bit more verbose. If you typically you start with -v. If that is enough, you're good and you move on. But if you somehow don't see exactly what's going on, you don't understand correctly, then you do the --trace and go from there. And what I wanted to also mention then is that well, if that is not enough, if that's just trace, and there's a version of it called trace ASCII also that shows a little bit more in text. If that is not enough, you add this trace config thing, which pretty much can ask curl to add even more to the trace, or add specific details to the trace. You can use the all one, which then adds everything curl knows, or you can do more specific transfer details around HTTP2, HTTP3, TLS, and so on. There's a bunch of keywords that can you ask curl to include in the trace output. Previously, or back in the days, this was only possible in debug builds, and it was always a problem for us, so that when people actually had problems with transfers and networks, and we wanted to get more information when we were troubleshooting, we would have to ask them to use a debug version. But now we don't anymore. Now everyone can get all the info from every version of curl. And you use like this pretty much. This particular then command line example here, it'll give you pretty much everything curl knows about the transfer, and it'll be very chatty. And in case you have problems, and in case you want to report that to us, that's a great command line to use. This is all the entire thing from the entire conversation, connections, handshakes, negotiations, blah, blah, blah. Awesome way to debug network related and protocol related stuff. I wanted to just remind you that the curl does bolded headers in the terminal, and it actually linkifies those URLs. In this case, the URL is a little bit bad example here, because it's an absolute URL. So a lot of terminals will just highlight that URL anyway, but curl will actually understand URLs and mark it as a URL. So a lot of terminals will actually highlight that and know that it is a URL when you hover your mouse over it, because curl has sort of marked it for it. And now it's suddenly just stuck there. Okay, and I wanted to just show you, talking about the helpers and things, that this is another new thing that is coming in the next release, coming in curl 8.10.0. As you can see, I've mentioned it twice now. It's going to be a feature, a release with a lot of new features and goodies. So this is a better option help. If you want to understand more what a particular option does, how it works, why, blah, 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 everything. You know, one of my pet peeves with the curl man page is really, if you do man curl and you want to read up about a particular option, then you do man curl and you search for -- whatever option you want to read about. And it'll be hard to find a particular option, because there's a lot of other texts talking about that option, and see also this option, and blah, blah. You have to type next, maybe 13 times before you find it. Now we have this particular way to find documentation about that specific option immediately in the terminal. curl-h and then the particular option name. In this particular case, -- fail early. So, and then it'll just blur out the help text for that particular option. It's the same text as from the man page, and it's pretty verbose. You probably want to type it to less in many cases. In this case, it actually fit on this terminal size at least. And it works with the long version of the command line option and with the short version and the no version. And yeah, I've already personally found this to be a really convenient way to get help for a particular option in a really good way. Yeah, and since we're on the topic of help, now someone asked me here, so how we can contribute to curl if you find a feature missing or improve something. So if you want to help out the project, then you just, it's really easy. We do everything pretty much the GitHub way. So you go to, well, you find the links on the curl.se site too, but you go to github.com/curl/curl. That's the home repository of curl. And there you can you file a new issue, you found a bug, you found a typo, you have a problem, we have misunderstood something, we have done something wrong, a regression, and report it, because we take all the errors, mistakes, bugs seriously, and we will fix them if we can as soon as possible, ideally. Or if you want to do an improvement and suggest a new fix, you make a pull request to curl on GitHub as well. And then you just sort of follow the GitHub model. You fork the repository, you clone it yourself, you do the changes, you commit your changes in your local branch, and you make a pull request on GitHub, and blah, blah. It'll appear in curl as a pull request to us. And then we take it from there. We review, we comment, we suggest, and we polish your work, your proposal until it's good, excellent, and then we merge, move on to the next one, on and on and on. And you'll see that we are really, if you want to help out in the project, we're really, no friction. We don't have any, it's kind of easy to work with us and to provide features. We don't have any bureaucracy or weird boilerplate things to fulfill, or that you have to sort of submit or do anything. You just do your best. You provide an excellent pull request. And if it's not excellent, we work together, we provide feedback to make it really excellent, and then we merge. So when that option help is really good, but we've done some other things too. And I mentioned previously, the skip existing thing, the skip existing feature that only checks the file on disk. If the disk is there on file, it will skip the transfer. But maybe you don't want that, right? Because maybe the file on the remote side has actually been updated while your local version is the old one and the new one on the site is different. And then e-tags is the perfect way to do that. That's actually the way HTTP is designed to handle this exact problem. You have a file locally. Has it changed remotely since you downloaded it last time? And typically then if it's a large file, right, you don't want to download it again just to see that it hasn't changed. 14 gigabytes. No, it's the same thing as the last time. Why did I download it again and wasted a lot of time and resources and bandwidth? So then you do this. When you download a file, you also ask curl to save the e-tag. E-tag is just a identifier that the server says this resource has. Basically, that's the server's tag. It's an e-tag for that particular resource. And you can tell curl to remember it. And the next time you want to download the exact same file, because you do it in a cron job or repeatedly or in a script or something, hey, I want to download it. I want to have this content. I want to make sure that I have the latest version or the current that the server has. Then I ask curl to compare the e-tag with the one we saved last time and only download it if it's different than what we have in our store already. So this is different than just assuming that it is the same file, right? We're asking the server if hey, server, send me the file if it's different. And if it's not different, skip it. And then in a typical use case, you would have this in a cron job or a script or something, and then you would use both. So send me the file if it's updated from the previous time. And if it's updated, save the new E tag so that tomorrow when I rerun this script again, it'll skip the transfer if it hasn't changed then, and do it again if it has changed. So this is a perfect one to just, if you want to run the script, if you want to check something really, really frequently, but it really, really rarely is updated, this is the way to do, because it's very lightweight way, and it doesn't load much on the server, it doesn't waste bandwidth, and it doesn't waste resources. An excellent way. And much better, they're much better than time conditions I added here, because curl can also do timed conditions, right? If the file has updated since this particular date, or this particular, has updated or has not updated, you can. So you can do that too with curl, but the E tag thing is more of a ask the server about the specific contents of the file, rather than this particular date stamp of the file. You can use that too. It's up to you. Curl offers all of that now. And the skip existing, which doesn't really care about contents at all. And I wanted to mention that curl also supports the alt service header, which is basically a server's way of saying that the same thing exists over there, hence the pointing finger, right? The same thing is over there on that server, on that port for this long time into the future. And you ask curl to use alt service by saving, or in this case, it actually both reads, but loads and saves this cache on a file on disk. So if it knows of an alternative place for this URL to download something, to get it from, it'll use the alternative instead. And the alternative can also use a different set of versions. It is, for example, the defined way how to find the HTTP 3 server. So how you go from any HTTP version to HTTP 3. And it's a cache that is a text-based thing. And the same thing is with HSTS pretty much. When you go to an HTTPS server and the server says, hey, I'm only going to be on HTTPS for this long time into the future with this header. And then curl, and you save that with curl. And the next time you then try to go to the site with an HTTP server protocol, not HTTPS, it'll automatically, transparently, internally switch to HTTPS, because that's what the server said in the past, that it's going to be available on HTTPS for this host name. It's a way to avoid accidentally going over plain text protocols. But these days, we talk HTTPS almost all the time anyway, so maybe not that common anymore. And of course, HTTP 3, we have that enabled as not experimental since a while back, and it changes how we do networks over the protocol, over the wire. So it's now done differently than HTTP 2 again. It's, for example, done over QUIC, which is a new transport protocol. QUIC is done over UDP. It's always TLS managed sort of within QUIC. So curl hides the differences from you, and but in this case, HTTP 3 is only available over HTTPS schemes in the URL, because it's always TLS in there. So yeah, and if you ask curl to do HTTP 3, it'll try HTTP 3 and fall back to one of the older ones if it fails the 3. And it'll do them all multiplexed and fun if you do with the parallel thing I mentioned earlier. So, and since this is such a fun HTTP 3 racing, I want to just explain the HTTP 3 racing because I'm so happy about it. So basically it means like this: when you want to go, we want to talk HTTP 3 to a server, or you want to try HTTP 3 to a server. That's the client that speaks curl. That's the server. You want to talk to curl.sc. You want to download a resource from there. And that's the DNS, right? So then we do like this. We ask the DNS, hey, what's the IP numbers or the IP addresses for that server over there? We get a huge list. This is actually the genuine IPv4 and IPv6 addresses for curl.sc, a lot of them, as you can see. 4 of one and 8 of the other. And then we fire off the first attempt. So we first start an attempt to do HTTP 3 over IPv6 to the server. And after a short while, we start the second attempt. And we try, if it hasn't already succeeded in connecting, we start a second attempt, which does HTTP 3 over IPv4. And as you can see, those three, they list a different set of addresses they try. And if after a while longer, none of these have succeeded, then we start a third attempt doing HTTP 2 over IPv6, and then a fourth attempt doing HTTP 2 over IPv4. So, so we start these 4 attempts in parallel with a slight delay between each. And the first one that succeeds, it wins, and the other ones are discarded, which means that if things are good, and if the server speaks HTTP 3 on IPv6, it's most likely going to connect to that pretty quickly, and then the other ones maybe not even start, or maybe if they start, they will be discarded since the winner takes it all here. And the delay here between the attempts is 200 milliseconds by default. So also that is also then intended to make sure that if one of these are terribly slow, for example, it'll not succeed fastest, so one of the others will succeed instead, and we'll go with that. That's also a great way then to fall back in case the server doesn't speak HTTP 3 at all. It'll just fail pretty quickly with HTTP 3 and then move on to the HTTP 2 attempts. And I should just also mention that on this slide here, I'm talking about HTTP 2, but they are actually negotiating HTTP 2 or HTTP 1. So the H2 cars here, the two below and the two at the bottom, they actually try to speak HTTP 2, but they will negotiate HTTP 1 if that's what the server wants. So basically then it'll try all the 3 HTTP 3 versions. So all of that, I mentioned a bunch of things that have been done over in curl the recent years. There are more to be said, but I've sort of just picked a few highlights and those that I think might be most important. When you go to this URL, curl.se/docs/options-when.html, that's the URL in the bottom here, you can see that we create one of these pages that just lists curl versions and which options that were introduced in that version. And why is that interesting? Well, it just shows you what curl command line options that we have added in recent versions. So as you can see from the top there, we haven't released 8.10.0 yet, so there's not a link on it, but that version will introduce 2 new command line options. The previous one, 8.9.0, introduced 4 command line options, and so on. It's a convenient way to figure out new command line options that maybe you haven't tried out yet, and you can click that link on the top there to sort an option name instead, and then get all those 265 options sorted differently. Just a convenient way to figure out about new command line options. And I wanted to mention that we're doing internet transfers here in the project and in curl, and the internet is not going to stop or slow down, and protocols and transfers are changing and evolving all the time. So we keep up with that. We follow along, and if they don't change, we can also change because of everything that happens, and we get new ideas and new things and new users and everything. And as I talked about how to contribute to the project, that's what we do, right? We're all volunteers. Well, not all volunteers, but this is an open source project. Everyone has a voice here. We can talk about it, discuss it, and move forward with whatever we think curl should have. And yeah, that's why and how you can affect what's next for curl. So there's a question about if there's a plan to integrate IoT safe for TLS, and I have to say that I have no idea what that is, so I cannot comment on that. But really, we don't plan a lot for what we work on with curl, but we go with what people want to work on and what people ask for, a lot of what customers, of course, pay us to do, and then what people contribute. And generally, if trends, protocols, versions appear on the internet and everyone seems to start using those, then chances are that we will go in that direction as well, because I mean, we want to make sure that curl is and remains the sort of the solid internet backbone for doing transfers, like it has been for quite a while, and that's what we would like it to do. So we have written this book called Everything Curl that documents pretty much everything there is to know about curl, the command line tool, the library, the project, how to develop for curl, how to write test cases, how to, yeah, pretty much everything. It's pretty thick. I think it's 550 pages or so in the PDF version. So it contains a lot, 114,000 words the last time I counted. So if there's anything you didn't understand or I was unclear about, vague, slurry, then go read it in the Everything Curl book, because it should be there. And again, you can help. This is open source. We appreciate your help. Tell us the mistakes, errors, typos, bugs, send your pull requests, and we can take it further into the future. So thank you. The next, in 2 weeks, I'm going to do a presentation called CVE, MITRE, CVSS, NVDC, and AOSS WTF at this Nordic Software Security Summit. I just wanted to mention that. It's here in Stockholm. So if you're here, maybe I'll meet you. Anyway, wanted to mention that. Questions, hit me up. I'm going to post both the slides and the recording is going to, both of them are going to be available after the fact. So just go back to wherever you found about this event, or just Google it and you'll find it. It'll be available very soon. So if there are no questions, thanks for hanging out with me today, and have a good evening, and see you in another curl related thing later. Bye.